Welcome to new features in T-Web Google Maps. Our agenda will be as follows. First, I'm going to introduce all the new features of the Google Maps component in TMS WEB Core. Then I'm going to introduce a new component, T Web Geolocation, new component to video tutorials. It has been there for a long time, but now that we build an example with mapping, this component fits right in. T Web Geolocation can be used to determine your location on a map. And finally, I'm going to give you two demonstrations of all the new features, including T Web Geolocation. There's quite a lot of new features in version 1.3 of TMS WEB Core for Google Maps. First of all, you can add waypoints to routes. So far, the only thing that was supported was going from A to B. Now you can define as many waypoints as you want between A to B. Further, you can optimize these waypoints using the Google Maps API. Drawing on the map has not been possible so far either. Now you can draw polygons, polylines, rectangles, and circles. The following example will draw a circle around our current position. The Google Mapping or Google Earth community has lots of so-called KML layers, meaning collection of markers or points of interest on a map with labels. These KML files can now be loaded into your applications. Another feature that has been introduced by Google to their mapping system are themes. Now you'll be able to use those themes with your Google Map components in TMS WEB Core. And finally, you'll be able to load GPX files. GPX files are used to log coordinates, and they can also be drawn on the map. So if you load a GPX file, you'll get a line of the coordinates that have been stored in that GPX file. Before going over to the demonstrations, here's the T Web Geolocation introduction. The component can be used to determine your current location. Be aware that your web browser might ask the first time you use the component if you allow this component to determine your location. This is something that has come up with HTML5 and security and has been introduced into all the browsers that are supported by TMS WEB Core. Because I have given my browser full rights to give away my location, this question is not going to be asked when I run the demonstration. The component will return latitude and longitude, and it works asynchronous, meaning you will have to implement an event to get the latitude and longitude after starting the component. You don't know how long it will take to determine your location. Sometimes there is not going to be a response, because if the user says, no, I don't want to give away my location, that event is never going to be called. So be sure that your application also works without getting a location from T Web Geolocation. This tutorial will not include one, but two demonstrations. The first demonstration is rather quick. I'll show you how to load a KML file. And the second demonstration is very detailed. It'll show you how to do the new routing with waypoints, determining your location, and how you can optimize your routes using the new Google Maps API. I prepared the first example. I didn't want to build it from scratch. So here we have a TMS WEB Core application with one form, and on the form we only have one UI control, the map of type TWebGoogleMaps, and the only setting I make in the code is setting the API key, because that is a requirement by Google. You cannot use the Google Maps API without specifying an API key, and I'm going to do that in the web form create event. Of course, I'm not going to give away my key, so I'm using a class specifically for this demonstrations that will deliver my Google key to the API key. The T Web Google Maps component provides a method to load a KML file, and because you're not really loading the KML file, you're adding a layer, a KML layer, meaning you can load multiple KML files. The method is called add_KML, and you have to provide a URL, and this is a biggie. You have to provide a URL. The Google Maps API will not allow you to specify a local file. So this file or this URL that you specify has to be hosted on a web server, meaning it will not work if you specify a file on localhost. This is a requirement from Google. This is not something that is not implemented in TMS WEB Core. Google simply has some security restrictions, and this is one of them. The second parameter you can set is zoom to bounds. Zoom to bounds means that if you set it to false, you will load the markers or all the stuff that's inside of the KML file, but your map won't move. This is not what I desire. I'm going to use the default value true. I want my map to be aligned perfectly, that you can see all the markers that are stored inside of the KML file. The KML file that I'm going to load is a KML file of some of the Major League Baseball stadiums in the United States. So let's see what happens. We see that right after loading the project, the KML file is added, and here are all the different ballparks, or some of the ballparks. Obviously there are more. There's Dodger Stadium, there's Fenway Park, and there's Citizen Bank Park. You get the labels, everything of that is stored inside of the KML file. So everything that's in the KML file is actually loaded using the official Google API. You can see that here, that you get the little helicopter icon. There's no support for shows in the Google Maps component of TMS WEB Core, but of course the icon is being shown correctly using the Google Maps API. One thing I'd like to point out is when we add the layer to the map. We use the map loaded event. You find that here in the events on map loaded. This is very important because you cannot add anything to the map before it is loaded. So you have to make sure that you put anything like adding markers, drawing on the map, you have to add that to the map loaded event, or you don't have to add it to that event. You have to make sure that your drawing takes place after this event has occurred. Also, assigning the API key after the form has been created is the perfect position. Of course, assigning it at design time is also possible. Just be aware if you assign it during design time that your key is going to be very visual inside of the source code. I realize, of course, that this tflixkeys class will also be compiled into JavaScript, and of course the code will be inside of the source code. Let's switch over to the more complex example. Like so often before, let me start by showing you what the application will do that we'll build step by step. First of all, you see that the theme of the map has been changed. I'm loading a custom theme that gives the whole map a bluish look. Further, on the top you have a list box with a couple of addresses of baseball stadiums. Another thing you might notice right away is that we are located in Sydney. Sydney is in Australia, and that is definitely not where these baseball stadiums are. So moving the map will take place by determining our current location. For me, that means it's going to be in Florida, so the alignment of the map will be perfect, even before calculating the route. The route will be calculated as follows. We start at the first location, and then we'll add the following locations as waypoints, and the last location will be the target location. Further, we'll have the option to move places up and down, and we can optimize the route asking Google Maps if there is a better route to take. So let's see. If we click travel, we travel from Fenway Park to Oriole Park, from Oriole Park to Yankee Stadium, from Yankee Stadium to Toronto, and from Toronto down to Florida. So here, this situation doesn't seem optimal, right? It would make more sense to go from A to B, from A to C to B to D, for example. Let's see what Google tells us to do. So we click optimize, click travel, and here you go. They pick a different route, which is better. We go from A to B to New York, from New York to Toronto, and from Toronto to Baltimore. So that is actually optimization using the Google Maps API. And the only thing you have to do is switch a Boolean flag from false to true. All the other things, how did we implement this? Let's start with the design of the form. On top, we have the list box. On the bottom, we have the map. The list box is hosted on a panel. The panel is aligned to the top of the form, so the map is aligned as client. So when you resize your browser window, the map will always be resized and the list box will always stay the same size. Of course, you could add a splitter component here to even make that variable. However, the number of baseball parks is restricted, so that's not really necessary. The move up, move down is something that we know from the VCL. I'm not going to go into great detail, but basically what we do if we move an item up in a list box, we first of all determine the current position. We exchange the two items that are the one that's on top, and then I'm going to set the item index to the current item that was selected before, so that we have the option to move one item from the top to the bottom without selecting it over and over again. The same thing for the button down click event. The same thing, just different ranges we have to check for. So this is all very similar to VCL programming. There is no difference. That's the strong point of TMS WEB Core. You don't have to think in a different language. You don't have to think in a different framework with different classes. It very much looks like the VCL, considering that you have a web list box, but it works just like the VCL list box. The same goes for the buttons and the events associated with that. Of course, the optimize is a TWeb checkbox, so not a T checkbox, a TWeb checkbox. Calculating the route is pretty easy, but it is a new feature, so I'm going to show it in great detail. First of all, we create a string list with the waypoints. So our starting position is item number 0, and the target position is the last item of the list. And in order to create the waypoints, I choose a cheesy approach. I added all the strings and deleted the first and the last. So we have the waypoints are the points in between the two. That's how we get to a list with just the waypoints, without the starting position and without the target position. And that's all we need, because if we look at the show directions method, which displays directions on the map, we need the starting location, we need the destination, we need what kind of route do we want. Of course, we want it with a car. We don't want to walk that distance. It doesn't make any sense. So we select the constant TM driving. And here's the waypoints, the string list with all the waypoints. I'll explain a little bit more if I show you the application again, how to specify the waypoints or the starting and target location. And here's the last parameter that I'm going to use, the optimize waypoints. That's exactly where you specify if you want the Google Maps API to optimize the route, or if you want to drive exactly in the order that you specified the waypoints. You have also the possibility to select to avoid highways and to avoid tolls. Those are the next two parameters, which are false by default. And that's it. That's all you need to do to display the route. With regards to the addresses, you see that you specify the street, the state, and the zip code. And as long as it's not outside of the United States, I don't even need to specify the United States. Here you see the Rogers Center is in Canada, so I also specified Canada. You can simply comma separate the different parts of the address. It's a simple string. So your waypoints are a string list of strings that determine the address. These are not locations. They're different methods that you can use to convert an address into latitude and longitude and vice versa. But the routing in Google Maps works with addresses. You don't need the latitude or longitude. The final part that I mentioned in the slides is the T Web Geolocation component. I didn't rename it. I kept it Web Geolocation 1. That's the name of the component. And I didn't change any of the properties. The only thing you need to implement is the OnGeolocation event. And this event simply gets two parameters, it gets three parameters, the latitude, the longitude, and the altitude. We are only going to use the latitude and the longitude. We're going to assign those parameters to fields in our class. And the reason for that is that we do not know when the OnGeolocation call will occur. The only thing we have to make sure is, and this is yet considering what we did with the KML file, you need to make sure that the map has been loaded. So you implement in your map loaded event the call to web geolocation 1.get geolocation. That triggers that you want to start determining the location where the user is right now. That will also trigger the dialog, and if the user takes a long time to click allow, this doesn't concern you at all. This event here is going to be called as soon as the geolocation has been determined, if ever. So if that ever happens, you call the method update location, and update location moves the map. How does that look? You call set center and pass in the latitude and longitude. Of course, you have to use the field variables because the parameters of the method are no longer valid. With regard to the map styling, you can do that at design time. You go to the options, property, and there you see the map style. And you have different map styles. By default, it's MST default. That means, I'll start it real quick. This way, the map looks like it did before. You can also see, we uncommented the get geolocation, that the position is changed to where we actually are, or where I actually am. I'm in Florida in the United States, so that works perfectly. You also notice that we were first in Sydney, it took a while, and then the map moved over, so you saw the asynchronicity there. So switching over to MST night mode will make everything look as you would wanted a GPS system to work during the night in the car, so it doesn't blind you while driving. So this is the night view. These are the two templates or the two styles that come with the Google Maps API by default. However, you can set this to MST custom, and you can set the custom style property. And the custom style is nothing else but a JSON file. I have a separate tutorial on Google Maps styles on the YouTube feed of TMS software. So have a look at that, how to get themes, how to use them, how to copy them over there. We already explained that in great detail. So after pasting the style into custom style and setting map style to MST custom, the component does exactly what you want it to do. You can watch your map in the style that you defined in the property. These are all the major features of the application, and also pretty much sum up the new features in the new version of TMS WEB Core. One thing I haven't focused on so far is the drawing on the map, and that is pretty easy. I told you, you have to do it after the map has been loaded. So we go into the map loaded event, and here we type map dot, and then we can say add. And there you see, in addition to add KML, we have add polyline, add polygon, add circle, add rectangle, and add marker. Add markers has always been there since the first version of TMS WEB Core, and just like you add a marker, you can add a circle. You need the latitude, the longitude, you need the radius of the circle, and you need a fill color and a stroke color. So let's do this. Let's add a circle around the capital of the United States, meaning Washington, D.C. So the coordinates, the parameters are latitude, longitude. That's Washington, D.C. Of course, separate video, you can convert addresses and city names into coordinates using components. And of course, and this is the thing you need to remember, you have to specify the radius. There is no default radius. So the radius is specified in meters. So let's say 500 meters is half a kilometer. So let's take 1 kilometer radius. Otherwise you won't see it on the map. As a fill color, and these are the color constant that you know from the VCL, CL red, stroke color CL blue, and the width 2, that's fine, and the opacity 0.5, meaning 50%. You can see that the default opacity is 1, meaning 100%. The default value for opacity is 1, meaning you can't look through it at all. And if you specify 0.5, you have a transparency of 50%. Let's run this again. Let's see if my coordinates were correct. Where is Washington, D.C.? There is Washington. And there you see our circle with a red center and a blue outline with 50% transparency, and I can even click it. I haven't implemented the events though. So you can also implement if somebody clicks on a circle, then you can get the number of the circle that has been clicked, or you can also access the internal JSON object of the Google Map API that everything is being added to if you don't want to keep track of your circles yourself. Or if you use a map that already has circles added to it after starting your application, you will need to use this parameter then. I think this has been a pretty detailed excursion of the new features of the Google Maps API in TMS WEB Core 1.3, and we also finally covered the component that helps you to determine your current location. Hopefully, you're just as amazed about the new features for the Google Maps API as I am. Stay tuned for more videos on web.tmssoftware.com, where you can also find other written tutorials and online demos for most of the functionality from TMS WEB Core.